Good. Hello, folks. Hope you guys are good. Good morning. Thanks for being here. My name is Fred. I'm the CEO and founder of Lerian. And we are going to talk today with you about the architecture of trust, transaction integrity for distributed systems. It's a very beautiful name, very beautiful title, just to say that we are going to discuss how to commit transactions in an efficient way in a financial transactions ledger. So, giving you a brief overview about myself. I'm a second-time founder. I founded a company called DOC in 2018, banking as a service business in Brazil. DOC is from Brazil, Lerian is from Brazil, and we both are also from Brazil. Currently, we are operating mostly over there in Brazil specifically, expanding bit by bit to other countries in Latin America. And I have together with me my dear friend and work colleague, Jeff, CTO of Lerian. Introduce yourself.
Yeah, hello guys. So thank you for watching this presentation. So I'm CTO and co-founder at Lerian. I've been working for 13 years with technology and financial systems, so you can realize in my head, so my gray hair. So I'm really happy to be here and share about it, Midaz, and some good practices to implement our solution, see if it works for you.
Great. Let's do it. We are going to talk about architecture of trust in the context of Midaz. So Midaz is our product. It's an open source financial transactions ledger. It's part of a much bigger solution that Lerian provides to the market, which is a core banking platform. So we have the ledger as open source, or open core, I would say. And we have a bunch of other plugins, modules, connectors that are closed source, and we sell them for our clients, and that's how we monetize the open source ledger. Going specifically about the ledger, we've built over the course of the last 2 years a multi-currency, multi-asset ledger with built-in FX engines. So it's able, our ledger, within our ledger, we are able to transact between dollars and BRL, Brazilian reais, dollars and Bitcoin, Bitcoin and heads of cattle, boxes of medicine, for us, whatever. So there is a built-in FX engine that does all the reconciliation and do also the FX transaction, the exchange transaction between the two amounts. It's also natively double entry with XY capabilities, and this XY here means that within the same transaction on an atomic basis, we are able to do X debits for Y credits. Of course, that the sum of the amount in the debit part must be equal to the credits part, but it's on an atomic basis, so our ledger commits this on an atomic basis. We also built, because of our experience in, let's say, other endeavors, we blended what we call a transactional ledger with a general ledger. So within the same ledger, we are able to create specific account types for some specific, as we say in Brazil, lines of the balance sheet or lines of the P&L. Enabling our clients to, for example, route fees for a revenue account, route taxes for some specific advancements that they need to do with the government for some specific accounts, and everything at the end of the day is reported on an accounting basis based on account types, transaction routes, and operation routes. It's fully auditable, immutable, tamper-proof, deployable in any environment, public or private clouds, as you know, it must be when we talk about open source software. This is a very brief overview about how we see the main entities of our ledger. So it's a multi-tenant ledger based on the number of organizations and number of ledgers. So within the same ledger, you can deal with different organizations, aka different fintechs, for example, can operate in the same multi-tenant ledger. And each of these organizations can have multi-ledgers, for example, dealing with different products that requires different types of bookings and so on. Another important, of course, another important entity that we have in our ledger is the accounts. So within each ledger, we can have a bunch of accounts, of course, and each of the account is parameterized with a specific asset. So within the same ledger, we can have accounts that transacts and holds money in different currencies or holds assets in different types of assets. We can segment accounts with our segment entity, and all these links with the transactions. Transactions for us is basically compounded of at least 2 operations, so 1 debit, 1 credit. Although, as I said, we can have a transaction that basically is X to Y, so X debits to Y credits being committed at the same time on an atomic basis on the ledger. And finally, all the chart of account and accounting stuff regarding account types, transaction routes, and operation routes that all together on a template basis enables our clients to extract balance sheets, P&Ls, regulatory reports, fiscal reports, accounting reports of any instance for their day-to-day operation. Going very briefly here, and then I will pass the mic here to my CTO. So the Midaz stack is basically a Go software. We've built the software on a modular monolithic way, so it's a monorepo, building different services that could scale, of course, on a different basis as well. We use RabbitMQ as our queue provider, event-driven async processing. We use Valky instead of Redis, and you know why. Postgres, MongoDB as our NoSQL for metadata storage, and we use Temporal for durable workflows, and actually for the building of any type of workflow within the whole context of our core banking platform. On terms of the microservices that we currently are building in the monorepo, we have the console, which is basically a Next.js web-based management interface. It's basically a front end built in Next.js to deal with all the APIs from the onboarding service that holds all the entities regarding organizations, ledgers, assets, accounts, portfolios, and segments. And we have a second the most important service here, which is the transaction service, that basically deals with the entire logic around authorizing a transaction over a balance or over a limit, and dealing with all the double entry operations, all right? Finally, as all open source software builders says, you don't need to believe in what we are saying, you don't need to believe in what we will say. You can see it for yourself. So our org on GitHub is Lerian Studio, /Midaz is our product, all right? So, Jeff, you have the stage.
So we're gonna talk about a 2-phase commit flow. Basically, we talk about phase 1, phase 2. It's the same way the Midaz executed the transactions, so committed the transactions. Breaking down into phases, phase 1, we have CQRS, separate readers from write is a pattern we're going to talk about ahead. Using idempotency to avoid the race condition, and balance control on Redis and or Valky cluster to control the balance and without to access every time transactional database. Asynchronous process, so we're going to talk about here the producer responsible to separate 2 phases. I mentioned it before. And phase 2, we have the focus on consumer, synchronous process, optimize database locking, so to guarantee the integrity, the database data integrity, and persist transactions and update balance. And the last one is the audit log, so it's important to keep the tracking what happened inside the ledger.
We're gonna be, exchanging notes here, complementing each other. But just to give you a context of, seems complicated for a ledger, but in Brazil we have a very specific scenario, which is we have since 2020 instant payments, aka PIX, which is settled in a matter of seconds. We actually need to comply with the 2 seconds to send the final response to the central bank in Brazil. And we also deal with a very, let's say, prominent space with banking as a service providers. And for banking as a service providers, there are some specific clients of these BaaS providers that requires a single account receiving a lot of credits and debits throughout the day and sometimes at the same time. So in Brazil, specifically because of the peak scenario and the clients of these BaaS providers that needs to have this single account, or as we say in Brazil, this basket account receiving a lot of debits and credits, we had to separate the transaction committee in 2 phases to give performance for our ledger. So what Jeff is going to explain here is exactly the phase 1 that requires the Redis, the val key here layer, and phase 2 that is more how we commit the transaction de facto to the Postgres database.
So phase 1, start talk about CQRS pattern, so idempotency and balance control. This is the pattern we are using on Midaz, the command query segregation responsibility. This pattern helps separate reads from write operations. Basically, what you need to, when your applications need to store some information to database, you have different business logic to treat it. So you have just a code to store the information to database. On the other hand, the query just retrieve this information from database, so they cannot change the state of the data. And some characteristics here, so architecture benefits to use the command, basically, so isolation of the write logic. So you have just a code prepared to write into database. Optimize for write performance. You don't need to worry about it, the read information at the steps, just to write this information. Better scalability, because you can separate reads from writes. And you can work together with event-driven architecture. You not just connect with database, but you can use event-driven or send events for consumer or downstream application. And clean boundaries, so commands muted states, queries never do. So this is one of principal objective this pattern. And query, basically isolation of read logic, improved for read performance. Multiple data source, because if you have application point for a data source in response to return just data for your API, you can have another data source to, example, extract a report, or don't share resources, or you have better performance. And independent scaling or read replicas. So if you need to scale your read replicas, you don't need to change the configuration, the main database configuration, just the read replica, so your application keep it working and storing transactions. At the same time, you are provisioning, improving the performance, the database, replica database. And it's perfect when you reads dominates writes operation, when you have to read have operations compared to write.
Just let me give a little bit more of color here. Imagine the use case. Imagine the scenario that we have many debit and credit transactions happening in a single account, and at the same time, we have the single account receiving a lot of requests for statements reports. So this is very common because of the way that the banking fintech system evolved over the course of the last 5-7 years in Brazil. So this is a very common scenario for us providers of financial infrastructure in Brazil. So this separation at the end of the day addresses these two problems very efficiently.
That's it. And now, after the talk about the CQRS, we're going to talk about idempotency because it's an important point when you work with money. And basically, can happen if you don't implement idempotency pattern because race conditions can happen in your application. Because if you don't have a method or a function synchronized, you need to guarantee the atomic operations. And if not, you can have double spending. So network failures can not help, but can contribute to race conditions happen. Because if your application is not prepared, you can send 2 or 3 network package, and duplicate this information, the transaction. So client-side bugs happen, so double-click or send 2 requests at the same time, so can happen, race conditions can happen as well. And duplicating events, because if you're working with event architecture, event-driven architecture, so your consumer needed to deal with it as well. And some problems you might face if you don't implement idempotency, double spending or charge your customer twice, inconsistent balance, so this moment you lost the database integrity, financial loss, someone needs to pay the bill, so normally it's the company have to pay the transactions happen more than time, yes, more than once. Regulatory violations and broken trust with your customer. Obviously, it's not a result, it's not the problem, but it's the result of the previous point. So you have to work more now if you have race condition, this application is facing race condition problem, because we need to work to recover the customer trust. And how to implement the idempotency to avoid the race condition. Basically, on Midaz, we are using X idempotency key and header in the request. So the customer can send this information, but if not send, the Midaz create a new one. And we are using SHA-256 to encrypt payload, transaction payload. It makes the transaction be unique. The scope of the isolation, like was already mentioned before, we have organization ID, ledger ID, and the hash is the transaction payload encrypted, the hash, so it's guarantee the uniqueness hash across the ledger. So if you have the same transaction happen in different ledger or organization, it's okay, it works, but when you have 2 transactions happen at the same time, the first one will be denied, will be processed, the second one will be denied. And why use Redis or Valkey cluster to deal with idempotency? So basically because enables distributed coordination among the nodes. So if you have 3, 4 containers working transactions, services working together, you need to point for the same cluster, for the same node, to everybody looking for the same place. This case, the application. It eliminates transactional database control because you don't need to go every time in transaction database, so it can be a problem, so performance problem ahead. And it's provide millisecond response times comparing transactional database. It reduces system load because I don't need to process necessary flows to guarantee the idempotency. Is the first thing I need to do is when requests arrive, I have to validate if it has already transaction being processed. So always connect with Redis or Valky. Scale horizontally, so if you want to expect it for our workload, so Redis can scale and help you to deal with millions of transactions at the same time. And here, so just a little draw about the solution. So we have X idempotency key, thread 1, thread 2. The service will identify who is the first request will be processed. Always connect with Redis, so distributed this information among the nodes. And the first transaction, in this case, thread 1, will be processed with success. And the second one will be denied because the customer will receive a response, something like, "Oh, I already been processed this message." So just try again, and few minutes later. No matter how many times you do it, the effect is the same. So it's a good definition for idempotency. If you have 1, 2, 3 transactions happen at the same time, doesn't matter, or millions. Always one transaction will be processed one at a time.
Just let me always connect what we did with what we, as a provider in Latin America, we face as a challenge. Imagine the scenario. The core banking platforms in Brazil or in Latin America, they are all built based on 3 main, let's say, buckets of way of being. So the first one is what we call the ledger. The second is what we call the messaging systems that connects this ledger with the local financial system. In Brazil, for example, one of the messaging systems is the Pix. We have the wires. We also consider the connection of the ledger with the card processors for transacting credit cards, debit cards, prepaid cards as a messaging system as well. The connection of the ledger with the issuance of what we call boletos in Brazil, which is basically a piece of paper for the customer to pay a bill. All these connections are what we call the messaging systems. And unfortunately, we have a fraud environment or a fraud, let's say, practice in Brazil and in Latin America that is kind of very much evolved, you know. The thing is, when you are the core banking authorizing the transactions that are coming through these different messaging systems, we need to make sure that, first, the idempotency works, and second, which is going to be the next topic of Jeff, the balance control also works. Because if we don't make sure that connections coming, transactions coming from these different channels are held at the same time with a very good balance control and with a very good idempotency system, something like, and you know, I'm not saying that this because we suffered in the past. Yes, we suffered. Transactions, millions of transactions, in a matter of 10 minutes, coming from the same PAN, which is all right, because at the same time, it comes with a different idempotency. But then debit transactions coming from the Pix channel at the same millisecond. And because of a small if in the code, these two things approved at the same time, were approved at the same time, and in a matter of 10 minutes, we are talking about losing $7 million. So someone with a POS machine swiping the card indefinitely, and it was a POS machine. We don't know how. And at the same time, millions of transactions of Pix coming from a different channel, and because of an if. So that's why we did this kind of control that is kind of crazy when we bring this type of logic for, you know, US and other countries, but we need to have it in Brazil and in Latin America.
Good. And now important point about the balancing control already is or Valky cluster. Basically, when you talk about it, Redis, the first thing comes our mind is Redis just for cache to increase the performance. That's it. But no, Redis or Valky are more than just a cache. So if your application, you can data start for transaction your application, works with queries, so rate limits, pub subsystem. Redis has these features can help you different ways. So, and if you have to work with hashes, data types like hash, set, list, or order, kinds of the data, so process atomic mode, so Redis can help you as well. And Redis guarantee the script atomic execution. This is a key point about this slide because this is the reason we use Redis to control the balance control for our customers. And to do that, we are using Redis or Valky together Lua script, so it's enable atomic operations. How works the business flows works basically. The application will retrieve the current balance from the primary database. Obviously, before that, we verify if already the balance is available on Redis. If not, they retrieve the current balance from the transaction database and store this information to this data to Redis. We set TTL, time to live, for a balance for 1 hour to work. Start to work from now with this balance. So this is the true now. And perform precise decimal place for financial calculates using the script Lua. Basically because, like Fred mentioned before, we can work with fiat currency, cryptocurrency, or different assets. So the Lua script is responsible to do this validation. And update the balance operations atomically. So we have to guarantee each transaction process one at a time. So, and after do that, so basically the script returns calculate balance to producer because, all right, so I did the balance calculation, I verified that this balance has sufficient funds to to continue the process. And now we start to work with asynchronous process to start the phase 2. That's all separating phase 1, phase 2. So talk about now asynchronous process. After have this information updated, this data updated, the balance. Why we are here, so many things are happening. So the word is asynchronous by design. So why is not in the financial system as well? Why we don't give the best user experience for your customers, so separate phase 1, phase 2, and improve the performance of the application using a synchronous process. So the advantage to do that is ensures reliable delivery, because if I have some problem with my consumer or another component, my application, when becomes available again, you try to process the information, the data comes from the query, the RabbitMQ in this case. It helps to prevent lost data or transactions because it's important. I already give the answer for our customer. It's okay. I respond. I accept your transaction now. I will finish. Enable the eventual consistency. Basically, I'm saying, so I received this information, but if I will take a little time to finish the process, but I will guarantee that. And support independent scaling for producers and consumers, so basically your applications need. And why asynchronous process? Because faster experience for the user, so we don't need to hold the thread for a long time. I just start doing the first validation like I mentioned before, and after that we send this information to start to process asynchronous, so the customer don't need to wait for throughout the process. Decouple the architecture, so we have more control what happened in your application. So and give maintenance for your code, etc., code maintenance, etc. Resilience to failure or safe retries. Some things not work perfectly, so you can hold this information until your application becomes available again. And you have more scalability, so you can scale up, scale down, your consumer or your producer based on your need. And a simple example how that's working on Midaz. User start a transfer operation. The service that source account and response using the update balance on Redis, was I mentioned before. The customer receive HTTP 201, so it's okay, I received, now I will finish the process asynchronous. And the credit account, so happen by, under consumer responsibility, and persist the update balance, the transactions, the operations to database. So this is what does producer do, basically just receive the transaction from the Redis after they updated this balance from the Lua script, because have to process one at a time. They send this data with perform any validation. The producer doesn't have a responsibility. The unit responsibility is just to send for consumer. And responsible solely for event generation, and publish the event to RabbitMQ exchange. That's it. And here, producer sent to exchange topic, and ahead we start the phase 2. So here, just a little example about the code. There is no a lot of responsibility here in this code. Just send this information to the exchange. Exchange is the topic on RabbitMQ. And just recapping the flow, we have we've talked about it. So CQRS, the pattern, CQRS, idempotency, balance control user Redis, and distribute cache, and Lua script together, and start to work asynchronous with event publish. So phase 2, we have consumer optimize locking, update balancing, audit log to finish the process and complete the transaction. What the consumer does, so this is responsibility, his responsibility is just update the account in the database, respond for persist the transaction, because we have the updated balance from the Redis, and we have the transaction from the source account and destination account to persist and guarantee the integrity, this transaction integrity to gather the database. And serves was fallback mechanism, because as I mentioned, so if something is not working perfectly, so have some problem, network failures or something like that, you can process this information later. And this is about the complete architecture, the flow, synchronous process, so producer, exchange topic, transaction, consumer, and database. But here's why Optimistic lock does. Basically, we prevent the conflicts without locking roles, because when we talk about working together, millions of transactions happen at the same time. You have to guarantee the right balance to be updated on database. So we use version field to control the version of the balance. So in this case, store together the record of the line in the database. It's improved the performance in low conflict scenarios because the Redis has the responsibility to increment this version every new transactions when it happen. And ours have to verify together the database. If the version is high, then the current version comes from the application. If yet, I did these updates. If not, I made these updates. If not, I just ignore this operation. And ensures data integrity without blocking the database, because I'm always looking for the row, not for the entire table, yes. And, right, okay, yeah. So, why use the optimized database in locking? So the advantage is allow high throughput, no locking, was I mentioned. Ideal for read-have workloads, you can read millions of data at the same time without locking your database. Simple retry logic, so if you cannot update this information at the moment transactions happen, you can do that after if you have some problem. And no deadlocks in your entire database. And so how it works, basically, the process to verify, to work together, optimize database unlocking. So each record has a version number to get the role in the database. And the versions field is increment version +1 in this case, or Redis of all key during the process of transactions process. This is this responsibility is the Lua script to do that. So every new transaction get the current version a +1. On consumer, just checks if the database version in transaction database is lower than expected version. What it means, so if it's lower, I can update because I am receiving the latest version from Redis. So this is the process to guarantee that my transaction database always updated. If they match, you update the record with a new version and balance. If you don't match, 0 rows in this case, we receive your code affected. So this keep because another update already happened. So this balance tried, the application tried to update it, was ignored because a new transaction already updated with a higher version. Basically, if the version field in database is lower than version provided by the application, the update will be completed. If not, just ignore, skip the steps because you are already the updated balance from Redis. So here are some key points to ensure the trust. Basically, when I talk about the transaction integrity are or nothing, there is no middle ground, so all or nothing. Prevent corruption from partition transaction commits, so to guarantee the transaction integrity in your database as well. Guarantee rollback on errors, something is not working, so a problem happened during trying to process the transaction, you have to guarantee the rollback. Database always remains in valid state after the failure, so never, like I mentioned before, so never try to, I will commit the first part and then I will commit the second part. No, all or nothing. And here's a little example in our code. We database transaction rollback, so we just verify in line 4, for example, if it exists some error, so there is some errors. If there, so basically we give the rollback. If not, we just commit the transaction, finish the process. And the line 14, you can see some errors happen. We just return this message to the queue to try to process later, because we using this flow, we don't lost the data. And other hands, everything's okay, everything's processed with success, so we just give the act, so and finish this process, commit the transaction, everything's working perfectly. And just talk about it, auto log. We have key points here, so auto log, because it's important to understand what happened inside your ledger, what happened in your ecosystem. The first one is append only transaction. So if a customer made a wrong transaction, the unique way to fix that is doing another transaction, so a rollback transaction, create a new one. Complete the operation tray, track everything, actions in your application to understand exactly what happened. Because if you have to do some troubleshoot, it's very important know exactly what happened. Correlation tracking, so traces the action across the service. In case of Midaz, Fred said previously, so we have a ledger, a core, and around the core we have different services connected. So we have to understand how these connections works, what the service is not work normally, so have some problem or something like that. So the tracking and so orchestrate your code with observability, tracing, etc. is a good practice to understand what happened. So it's tamper-proof, logs are immutable to prevent manipulation. So here we are using Trillium to gather our stack to basically to guarantee everything is okay. There is no change before the transactions is stored. And here, a little example about observability. We have some plugins that was Fred mentioned before. We have fee, wealth, and onboarding. It's one of Midaz domain. You can see everything is what happens, so using the observability in our stack. And if, for example, have a problem with plugin alpha plugin, so you can see easily, so and take control about what happened and fix the problem faster.
Just to give context here, the auth plugin is, as the name says, they're responsible for dealing with authentication and authorization. So it's not part of the open source stack, but we provide it for those clients that want it. We provide it as a plugin. And the plugin fees here, for example, is one of our engines, one of our plugins that embeds fees, taxes, any kind of charge into a transaction before the committee of the transaction. So this is something for our clients to decide that, I don't know, for a PIX transaction, I want to charge $1, whatever. So this plugin is the one embedding this kind of data into the transaction payload.
And so building a trust, so here's some key takeaways. Basically, don't work with synchronous requests. Try to separate the phases, as I mentioned before, because you have take full control about the request, and try to separate the read and write operations in the same database. It's a recommendation. We know if you have money, because when you create a replica database, it can be expensive, but it's a good practice to follow. Never forget to handle with a race condition. Our experience is not so good in the past. And implement the error handler to improve developer experience. So here, thinking just about thinking in developer to understand if something's not working in your application. Try to handle the best way possible to give the right answers if your application is not working well. And keep in track of the transaction lifecycle through the observability. So, as I mentioned before, so try to do that. Your operation teams will thank you. And append-only design, immutable financial records when you work with ledger financial system to keep the tracking out throughout the process, throughout the history of the application. So thank you from Lerian team. Thank you, Fred, everyone.
Just one thing here before anything. This is the first presentation in English of our CTO. So if you could help me. He was super anxious, super nervous, but you did it, mate. You did it. Man, finally here, so final words. With all these things together, we are talking about reaching numbers like 5-6 million transactions per minute in our ledger. And when we consider single account transactions, we can reach numbers like 18,000 transactions per second in a single account. Everything is decoupled, is detachable, so if something fails, of course that we are going to lose performance. But everything together, considering here a system with 4 cores, 64 gigs, we can support clients that requires from us in Brazil in some specific, spike times, numbers like 8,000-9,000 transactions in a single account happening at the same time. This is something common for you to guys have a sense. So, yeah. Yeah, again, don't believe in us. That's the good part about, being open source and trying to disrupt a kind of legacy environment, legacy field. So test our systems with one single command. We have a time to first transaction in your own machine of something around 2-3 minutes using Docker. So test it, send us suggestions, critics, and thank you very much for being here. Thank you. Não, não tem tempo. Yeah. No, they are in the same general ledger, but they are domains that are different, you know? And everything at the end of the day is put together by the reporting engine, you know? So the reporting engine, at the end of the day, they get everything that is happening on the onboarding service together with everything that is happening on the transaction service. When we say that we put together the transactional with the general ledger, means that we, at least, you know, as we understand these two things in Brazil, means that from a single financial transaction ledger, we can extract balance sheets, income statements, and even cash flow statements without the need of exporting and aggregating this data into an ERP, for example. You got it? So no matter what the payment rails are, everything is going to be reconciled together, and at the end of the day, you don't need the SAP ERP, you know, whatever, to aggregate the accounts for you to have a sense of what's on your assets, liabilities, shareholders' equity even, if you keep track of that on the ledger. And also, you don't need the ERP for you to have a sense of the income statement of the financial institution. Yes? You work on? You can use? Totally. Great question. So eventual consistency here for us is a pattern, definitely. But at the end of the day, in the way that we built our system, the eventual consistency at the end is delivering a committed transaction. Because if everything is happening on the Redis, on the memcache level, and it's the memcache level that deals with the balance control, idempotency, and even the versioning that later is going to be persisted to the database, at the end, the eventual consistency, the fact that we are delivering a 201 to our client means that the balance or the credit was debited or credited. So the thing is, if something happens between the memcache and the persistence of the database, that's why we need something that stores the queues, stores the messages in in something physical, let's say, for us to not lose tracking of that. But anything at the end of the day is coming from the database on a spot basis. Everything is at the end of the day dealt at the memcache level. At the end of the day, we have a synchronous flow because of the memcache, if the balance is updated there within the TTL that we currently have set. And eventual consistency is only for us to avoid dealing with the database on the hot load performance. Good. Do we have time for more one? One more. Exactly. Great question as well. We don't care if they are coming at the same at the right order, because at the end, the payload, or the structure, the data structure that follows the versioning has all the back information regarding the updated balance. So if we get the V2 before the V1, the updated balance is going to be in the message. And that's what, at the end of the day, is important for us. Because some point in the future, the V1 is going to come, and then we are going to place the transaction in the right order for the statement report. But for the balance or the limit updates, for us, it doesn't matter if V1 or V2 is going to come to the database, the order of that. Exactly. And that's the important thing. Exactly. That's the important thing, because at the end of the day, what matters, to be sincere, our clients, the clients of our clients, they don't think that the user experience of receiving a statement, at the 0 second after the transaction is something meaningful. What matters is the update on the balance / credit limit. Thanks. See you. Bye-bye.